All right, sorry, I got kicked out of my last recording there, but we were just finishing this problem here. So you can see on top we have that 3 left over, now x to the 7th over x to the 5th, if I'm looking at these two here. X to the 7th, if you remember back to our very first test, is all of that, and then x to the 5th is 1, 2, 3, 4, 5. So x, all those cancel out to 1, which leaves me x squared left on top. And now the y's, so if we have y cubed, that's y times y times y, over y to the 5th, then we would see that 3 of those will cancel, leaving y squared on the bottom. So our final answer there is 3x squared over y squared. Okay. Moving on. We have just a little bit bigger version. Now these are larger factors. They're binomial factors, but they're still all multiplied together. So once again, we can just pretend this is one big fraction, and these are just multiplied. Everything's just multiplied, okay? So I have an x plus 1 on bottom, an x plus 1 on top, x minus 2, x minus 2. So it looks like on top we have, so we do have a 5 and a 10. That would reduce to 1 over 2, right? And then, so 1 over 2, which you don't need to write the 1, but I'll go ahead and write it for now. And then we do have this single x that's left on top. And then on bottom, we have 2 factors that made it. So we have x minus 6 and x minus 1. Okay, and you can just leave your answer factored. Okay, so that's what's left for your answer. Now this one is just the unfactored version of that, but once again, you can see this is all multiplied together. The parentheses aren't there, but it's assumed by the way that the fractions are given. So if it's not factored, if each individual quadratic or polynomial is not factored, you got to factor those. So I'll do different colors here. So this one on top, so the factors of 3 that add up to 4 would be x plus 3 and x plus 1. Times, and it's all multiplied together. So on top here, the factors of negative 10 that add up to negative 3 would be x minus 5x plus 2. And then on bottom, the factors of 6 that add up to 5 would be x plus 3 and x plus 2. And then the last one, that's not a trinomial, it's a binomial, and both of those terms have an x. So if I factor out an x, that would leave behind x plus 1. So that's just a GCF there is really all we can do with that. Once that's the hard part, the next part's the easy part. You just cancel all the common factors. It's all multiplied, so x plus 1 cancels with x plus 1. We have an x plus 2 on top and bottom, an x plus 3. So the only thing that's left is an x minus 5 on top over x, this one x here, okay? But be careful, like we talked about earlier in part 1, those x's do not cancel because the x on top is subtracted, or x5 is subtracted from x. So I cannot cancel those x's because the x on top is not multiplied. That's your final answer. All right, and the last thing we have to do today, we just got 2 slides left, so this part will be a little bit shorter, is dividing rational functions. And it's really easy. There's just one little thing you got to remember, and I'm going to send you back to middle school. I know a lot of the teachers in middle school teach keep, change, flip. And what I mean by that is when you're dividing 2 numbers, whether it's just numbers or rational expressions or anything that's a fraction, if you're dividing, you just keep the first number. So on this first example, you keep the 4. You change the division sign to multiplication. So keep, change, and then you flip the second number upside down, the reciprocal. So 2 is 2 over 1, so that would be 1 over 2. Okay? Our mind typically does better with multiplication, especially when I have a fraction and another fraction. You'll see that here in a second. And we all know that 4 divided by 2 is really just half of 4, right? So that would give us 2 as an answer. Okay, so we call this keep, change, flip. So the second example here, if I have 8, divided by a fraction is confusing. 8 divided by 4/3, that doesn't even make a ton of sense. So what we do is we keep the first number, we change the sign to multiplication, and then we flip the second number upside down. So instead of 4/3, we write 3/4. And if you want to think of this as 8 over 1, right? If we multiply fractions, it's just straight across the top. So I would get 24 over 1 times 4 on bottom is 4, which we know could simplify to be 6. In other words, 4/3 of 8, or sorry, 3/4 of 8 is 6. Okay, and then the last one is fraction divided by a fraction, which is really confusing. So keep the first fraction, 4/3, times, flip the second fraction upside down, and then you just multiply straight across. So 4 times 5 is 20. 3 times 2 is 6. If we divide each of those by 2, we'd get 10 over, sorry, divided by 2 would be 10 over 3. 10/3. Okay, now the same thing happens for this big rational function. It's the same concept, okay? And I'm going to kind of factor it as we go. But the first fraction stays the same. Nothing changes about it. I am going to go ahead and factor it, though. So on top, the factors of -12 that add up to -1 would be x minus 4x plus 3 over, and then the factors on the bottom, the factors of -4 that add up to -3 would be x minus 4x plus 1. So we can already see a factor that's going to cancel there. But then you change the sign to multiplying, and then you flip the second fraction upside down. So this becomes x squared plus 3x plus 2 over x squared minus 9. And now down here, I'm going to go ahead and factor that. So on top, the factors of 2 that add up to 3 would be x plus 2 and x plus 1. And then on the bottom, we have a difference of perfect squares. X squared minus 9 would be x plus 3, x minus 3. So lots of factoring here. That's kind of why we did this little factoring review in the module before the last one. And then once it's multiplying, that's the easy part. You just pretend it's all one big fraction and just everything is multiplied together, right? So the -4's cancel, the +3's cancel, there's a +1 that cancels. The only thing left on top is x plus 2. The only thing left on bottom is x minus 3. Remember, those x's do not cancel because they're not multiplied. We cannot divide away x's that are added or subtracted. Okay, so pretty easy. You just got to keep, change, flip, and then it's basically what we've been doing this whole lesson. Okay, last one, I'm going to let you do this one on your own. So take a few minutes, go ahead and pause the video, give it a try, and then I will go over it here when you're done. All right, hopefully you gave that a try. So you can see I kept the first fraction the same, but I did factor it. I changed the sign to multiply, and then I flipped the second fraction upside down, okay? Once it's multiplied, we just pretend it's all one big fraction, okay? So I do have an x plus 3 on top and an x plus 3 on bottom. And then this single x will cancel with one of these, so that would just leave x squared on the bottom. X over x cubed would just be 1 over x squared, okay? So the only thing left on top is x plus 3 over 4x squared. And that's the best we can do there. There's nothing else that is multiplied that we can divide away. All right, that is all for the lesson, and this will be the only lesson for this week. So go ahead and go back to the module and make sure you read the directions clearly and complete the practice that goes with these two videos. Thanks for watching.